Thank you. So I'm delighted to be here to have this opportunity to tell you something more about Accelerate Zero. It's a new initiative that we're trying to get off the ground. We're backed by the Henry Royce Institute as part of their translation agenda. And, It's a unique partnership between industry and universities to accelerate climate solutions based on new materials. It is an accelerator of commercialization of materials from universities, but not a traditional kind of accelerator that's based on forming new companies. This is about focusing on the development of those materials into opportunities that are attractive to industry. And as Bill Gates said, to avoid a climate disaster, we need lots of breakthroughs in science and engineering. And one area in particular is we need lots of new materials with enhanced capabilities and improved performance across sectors, from energy to transport, the built environment, and electronic devices. And luckily, around the world, particularly in the UK, supported by places like the Royce Institute, these advances in materials are taking place. But what we need to ask ourselves is, are these materials going to be able to get into next generation products in time? Are they going to be available to help us avoid a climate disaster? And sadly, with the development pathways that we have available to us at the moment of taking research from universities and into industry and into the marketplace, we're not going to get there in time. We don't have the infrastructure or the ecosystems in place that allow us to take early stage innovative materials into industrial rollout in time. Universities do have the disruptive innovation, and here are some of the sort of groundbreaking new companies that have been formed in recent years. But all of these companies suffer from the same challenges of needing to overcome scale-up and integration issues. And this means that the timescales of taking materials innovations from universities into the marketplace are typically timescales of 20+ years. For example, the innovation that underpins the lithium-ion battery took 26 years to go from lab to kicking off the electric vehicle market of today. Oops. This does not want to move on now.
Can you do it on the computer?
Yeah.
Try and press in the space bar.
Nope.
No.
We've frozen. Do we need to reboot?
Thank you. What we need is a radically different commercialization pathway that takes these 20-year timelines and reduces them down significantly to the order of 7 years. And that's what we're trying to do with Accelerate Zero. This is our initiative to actually bring together the game-changing innovations from universities in materials, new materials, and pull together the expertise of industry in integration and scale-up of those new materials into next-generation products. The model is based on a model that's been used in 2 other areas of therapeutics and agri-tech to put some money into a pot to fund that development work that's required to take those groundbreaking innovations and develop them into opportunities that are attractive to industry, to create minimal viable demonstrators that de-risk those opportunities sufficiently for industry to take them forward, reducing the commercialisation timelines. What we want to do is to get this initiative off the ground. We want to run a pilot for 3 years involving 6 universities, 5 industry partners, a £5 million pot to support 12 de-risking projects. We have the 6 universities, 6 of the top material science universities in the UK, Manchester, Oxford, Cambridge, Imperial, UCL and Bristol. We have the backing of the Royce Institute, which is really important to us because this is a sector-wide materials problem to overcome, the timescale that it takes to overcome the scale-up and integration challenges. And we're now talking to industry partners, global materials-focused industry partners, who see the opportunity to increase their competitive advantage of getting this visibility of the research innovation that's coming out in the material space from universities, and a defined acceleration pathway for those materials to help them achieve their net zero goals. And if this pilot is successful, then we want to expand it to include more companies and more industries, and become the way in which industry works with universities to make sure that they benefit from the materials research undertaken at universities. So I hope that you've enjoyed learning a little bit about Matcelerate Zero. If you want to learn more, then we have a website called matceleratezero.com, and you can come and talk to me. I'm here for the rest of the day. So thank you very much.
Thanks, Gillian. New and exciting. It almost overwhelmed the computer, didn't it?
Yes, I think so.
Questions?
Hi, Gillian. Thank you very much. Daniel Napper. Just with regard to industry collaboration, how would you as an organisation anticipate handling the IP and the foreground IP created when you have collaborative partners and there might be co-funding models taking place?
So the translational work that would actually happen, we don't really envisage a great deal of foreground IP arising, because the funding would be used to take an early stage material that's been protected within a university and undertake the scale-up and integration work at a third-party developer. So they would be applying their known techniques to scaling up that material. So we don't really see that part as being particularly innovative. If something does come out of that, then that sort of foreground IP would be very much associated with the background IP. So it would reside with the university from which that technology has come. So the funding model is that all of those companies put money into a pot, and they're all collectively on an investment committee deciding, well, which of these opportunities from universities should get that funding. So it's very much about sort of sharing the risk of the development project and then sharing the reward.
Edmund.
So you've got projects of 350k to 500k, I think. That's obviously great for the projects, but do you think that's really enough in terms of making a rapid change because you might want a team of people working on it to make rapid progress, in which case 350k, good though it is not going to go that far?
I think the sum of money came from looking at actually what we'd managed to achieve to develop the technologies that have gone into spin-outs. How far did we need to take those before investment committees would decide to invest? And with the typical sums of money that you can get available either from sort of the EU or EPSRC for doing translation work, that's typically in the order of sort of 100 to 200k, and that allows us to get to that point, being very sort of strategic about. Sorry, I know that. Did you want to interrupt? No, okay. To get to a point where you've de-risked sufficiently to do the next step. So we think that 350k to 500 is significantly more than that. So will enable us to make some really significant changes. And the industry partners would be telling us, exactly what do they need to see before it's de-risked enough for them to take the technology on.
Rob, did you want to?
Yeah, just following up from that. So the next stage investment, do you work largely with the major industries who would provide the funding for continuity, or do you have gearing opportunities through VC or other methods?
We're talking to a lot of people at the moment. So talking to the corporates themselves who we want to put money in because it provides them with an advantage at the end. They, for their money, I suppose they get this visibility of what's coming out of universities earlier than normally people get visibility. Normally they have to wait until we do a spin out. There isn't sort of a mechanism to engage industry effectively earlier than that. We're also talking to VCs and figuring out how they could be involved in this, because obviously they have a lot of corporate partners. We're talking to the venture arms of the companies, which seems to be the most successful route that we have of engaging with those companies. But we've also put in a bid for Research England money as well to try and sort of get this off the ground, because I think it's quite difficult when you're doing a new model for companies to not worry, because you can't show them that it's going to work. We can point to the therapeutics field, we can point to agri-tech, very different areas where a similar model was successful, but we can't show that in materials that it's going to work.
I think that early engagement is a really important part of this, Rob, and then bringing that industry insight into what the barriers or what the opportunities are to accelerate. So I think that's a key thing more than the money and the IP. In effect, so if we're not careful, things like the IP and that's sort of blockers, and we're trying to think, let's cut through those.
Yeah, I'm interested because you're talking about mirroring the agri-tech and the other sectors. One of the things that helps those sectors to get a route to market a lot quicker is they have extremely robust validation methods, right? We are in a sector where validation methods still are being developed. How is potentially some of that money could be spent on not necessarily trying to get something to market as quickly as possible, but actually developing more robust validation methods that permeate throughout the sector?
I think that's a really interesting point. I mean, obviously we're working very closely with the Royce, but what we're looking for really is for those companies to tell us what do they need to see, and if there isn't a method to validate, then we'll obviously need to be engaged in sorting out how does that happen. But I think because the translation work that's done will be done in the very best place to have it done, whatever the third-party developer is, whether it's it's at the Royce or the CPI or an OEM that does the development work. I don't know if that answers your...
I think, just to add, it's a really important point, and there's a rollback to NPL and others in that regard, and looking at the veracity or verification of that data. But I would argue that that's what industry, that's exactly the thing we're wanting the industry to say, well, this is what we need to move this forward. So instead of, if you like, the academics saying, well, these are what I think the priorities are, it's actually getting that insight from the industrial pool to say, well, no, actually, these are the priorities that we need to pull things through. So it's just getting that two-way conversation. And it might be exactly what you said, or it might be something completely different that we haven't thought about, and we just recognise that's one of the barriers. Okay, one last question, and then we'll...
Can I pick up the point you just made there? You've got a marvellous suite of materials organisations. You've got corporates. One of the things I've certainly found in terms of pull-through of materials more quickly is to get the advice directly of the design community who are closest to the market, and can therefore advise backwards in terms of those important decisions, in terms of which one to select. I've found that the design community can often spot winners far faster than the material organisations.
That's a really interesting point, so I shall bear that in mind.
So I think you've touched on a point which we're implicitly aware of. So we do see those organisations that don't just make material, but they turn material into functioning devices, and they're the people that recognise a lot of the challenges that come through. So I think those are the people that we're looking to get engaged here, actually. So I think we're trying to, unless you mean something different in design.
Something completely different. I'm talking about those business consultancies, those design business consultancies. And there are thousands of them that are getting briefs every day of the week and are looking for new materials to solve those problems. And talking to them, what they say to me as a materials technologist is, we want to know at the light bulb moment of the material development. Not when it's there, not during the scale up, but we can advise you in terms of whether that will meet our design needs. These are very different organisations.
Yeah.
Okay, that's some.
Yeah, I was just going to say, I think, though, that what we're talking about is actually before the designers would be to get involved. There are so many questions about the new materials. You know, we've got a gram, can you make a kilogram? So it's not massive scale up, it's just that initial bit that allows people to have enough material to play with to do the testing that they want to do. And I think maybe after that, then, you know, the input from the sorts of organisations that you're talking about is really important.
I'll follow up with you after. I think we're going to have to pause there, otherwise we're going to overrun. But thanks very much, Gillian. So,
Thank you.